So our next presenter, Karisa Parkington, working with Dr. Roxanne Itier in the Department of Psychology, will speak on looking eye to eye, facial context and featural fixation modulate early neural markers of face perception.
As humans, we are highly social beings. Whether we are spending time with family, socializing with friends, or presenting in front of an audience, we are almost constantly interacting with other people. As such, we have developed a specialized set of social behaviors to help us navigate our world. One of these specialized behaviors is the ability to process faces as a glued-together whole, which is referred to as holistic processing. This allows us to process faces quickly and efficiently in order to update our social interactions. But when holistic processing is disrupted, we tend to process this information on a part-by-part basis, much like the pieces of a puzzle. Previous research has also shown that attending to the eyes helps improve many different social behaviors, including the ability to process faces as a whole or recognize who someone is. Because we interact differently with people we know than we do with strangers, I'm interested in understanding how the brain responds to changes in facial configuration and identity. For my master's thesis, I began to address this issue by asking the question, how do we process faces and facial features? I measured the brain activity of 33 adults while they looked at pictures of faces and facial features like eyes, nose, or mouths on a computer screen. Brainwave activity was measured using EEG, which picks up the brain's natural electrical activity through electrodes that are placed on the scalp. I also used eye tracking to monitor where the participants were looking. I found that faces are processed faster and more efficiently than isolated features, and I found that where you look on a face matters. In fact, focusing right between the eyes produces the fast and efficient brain response. But most importantly, I found that when individuals look at isolated features, there's a faster and larger brain response to the eyes than to other features like the nose or the mouth, suggesting that the brain may have a specialized mechanism for the detection and response to the eyes. This research is critical for helping us understand how we process social information, the most salient information in our environment. So where do we go from here? For my PhD, I plan to extend this research further to understand the direct link between attention to the eyes and identity recognition. I'm also interested in understanding what happens in the brain when these specialized social behaviors break down. Imagine living in a world where eye contact is physically painful or extremely anxiety-inducing, or where you have difficulty recognizing people around you. This is the reality for many people living with face blindness or autism. Autism is a pervasive lifelong disorder affecting as many as 1 in 68 individuals across North America, making this one of the most relevant mental health concerns facing Canadian families. It is my hope that my research can lead to the development and implementation of evidence-based services for those affected by face blindness or autism to help them live their lives to the fullest. Because remember, we all strive for social connection.